Okay, so we have looked at the first 3 out of the 4 basic techniques for solving a quadratic equation in this section. So the last one that we'll look at here is using the quadratic formula. Okay, and for example, it says the solutions to ax squared plus bx plus c equals 0, a is not 0, a, b, and c can be any number, a can't be 0 though, are given by x equals negative b plus or minus the square root of b squared minus 4ac over 2a. By the way, here's one reason why a can't be 0, because I can't divide by 0. The quantity b squared minus 4ac, which is underneath the radical, is called the discriminant of the quadratic equation. And the discriminant is kind of important because it tells us if the solutions are going to be real or imaginary. Item 1, if b squared minus 4ac is some positive number, then you're going to have 2 different real solutions. Okay? If b squared minus 4ac is less than 0, then you've got a negative underneath the square root sign. And so that would mean that you're going to have 2 different complex solutions. And if b squared minus 4ac is equal to 0, then that would mean that you're going to have a repeated solution. Also, you're going to have a repeated real solution. For example, suppose that 2x squared minus 3x minus 5 is equal to 0. Well, if a is 2, b is negative 3, and c is negative 5. So x is equal to the opposite of b is 3, plus or minus the square root of b squared, negative 3 squared is 9, minus 4 times a is 2, times c is 5, negative 5. All over 2 times negative 2 is, 2 times 2 is 4. Okay, so we've got 3 plus or minus the square root of 49 all over 4. Okay, now the square root of 49 is my discriminant. 49 is a positive number, so I should expect to have 2 different real solutions. Okay, well, the square root of 49 is 7. So I get 3 plus or minus 7 all over 4. 3 plus 7 is 10. 10 over 4 is 5 halves. 3 minus 7 is negative 4. Negative 4 over 4 is negative 1. By the way, this is an equation that could very easily be factored in solving. Here's how I'd factor. 2x minus 5 times x plus 1 equals 0. Means that x is equal to 5 halves and x is equal to negative 1. Are the 2 solutions. Okay. So let's take a look at another one here. We got 2x squared plus 4x plus 1 equals 0. Okay, well, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b would be negative 4 plus or minus the square root of b squared. 4 squared is 16. By the way, when you square b, you're always going to get positive. Okay? Minus 4 times a is 2, times c is 1. And this is all over 2 times 2. We get negative 4 plus or minus the square root of 8 all over 4. Okay, the square root of 8 is a positive. And so that tells me I have got 2 different real solutions. Okay, well, the square root of 8 is 2 root 2. And so 2 is in common to the 2 terms there. I can factor that out. And 2 over 4 is 1/2. Okay, when I factor 2 out, of the numerator. That leaves me with negative 2 plus or minus root 2 all over 2. Negative 2 plus or minus root 2 all over 2. Okay. By the way, here's a reason why I would not factor, is because I see these two numbers here. That would be the two factors. By the way, in terms of a process to solve, the first thing that I'm always looking for whenever I solve a quadratic is factoring. Okay, factoring is going to be by far and away the easiest method to use out of any one of the other three methods. Okay, the second thing that I'm looking for is to use the quadratic formula. Okay, the quadratic formula is going to be easier than using the completing the square method. Using the completing the square method takes some time, and one little slip up and there goes the whole problem. Okay, and so consider that. Consider that when you're solving for x, that if the problem doesn't factor to begin with, then use the quadratic formula. Okay, then I'm using the square root property if it applies, and then completing the square. Okay, so let's try out 4x squared minus 5x equals negative 2. 4x squared minus plus 5x plus 2 equals 0. Well, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I got the opposite of b, which is negative 5, plus or minus the square root of b squared. 5 squared is 25, minus 4 times 4 times 2, all over 2 times 8. 2 times 4 is 8. So I get negative 5 plus or minus the square root of negative 7 all over 8. The square root of negative 7, in terms of a complex number, is I root 7. So I got negative 5 plus or minus I root 7 all over 8. And that doesn't simplify further. That's as simplified as it's going to get. So the way I did this problem would be the best way to do that, to do the problem. I would not want to factor, okay, because these nasty numbers are the factors. So yeah. Now I would like you to know all 4 of the techniques. Okay, I will tell you which one of the 4 techniques to use. I want you to know all 4 of them though. But as we go along, if you're given the option, which is going to happen a lot, the first thing that I'm thinking of is factor. Okay, and if factoring doesn't work, then the next thing that I'm thinking of is using the quadratic formula. Okay, in some special situations, would I consider using the square root property? I got to be all set up to use the square root property though. Like so. I've got an expression that I'm squaring equals a constant. One of those two. Okay. Give the special factorizations. If we're factoring, suppose it's x squared minus a squared. X plus a times x minus a. X squared minus a squared. Sorry. X squared minus a squared is x plus a times x minus a. Okay, now we don't have a nice formula for the sum of 2 squares, x squared plus a squared. Okay, we just say that that's prime. We're adding. Although we do have fairly nice formulas for when we're adding and subtracting the difference of 2 cubes. Okay, when you're adding two cubes together. Suppose x cubed plus y cubed. X cubed plus y cubed is going to factor as x plus y times x squared and y squared, minus xy plus y squared. Okay, and the way that I remember this is to say, well, you're going to start by taking a binomial times a trinomial. Okay, so something that has two terms times something that has three terms. The something that has two terms are the things, the two things that you're cubing. Okay, so for us it's x and y. The first and last terms are the two numbers that I'm squaring. Okay, so it's x squared at the beginning, y squared at the end. And in the middle, I'm subtracting x times y. Okay, x squared minus y squared, x cubed minus y cubed, it factors as x minus y times x squared plus xy plus y squared. Okay, so the way that I would basically it's just remembering the signs. Same, different, plus, same, different, plus, and so you know, if I have a plus sign, it's the same sign, different sign, plus sign. If I have a subtraction sign, it's the same sign, different sign, plus sign. And so I'd use that for this one. X cubed minus 3 cubed. 3 cubed, 3 times 3 times 3 is 27. Well, that's going to mean I'll have formula number 3. Okay. X squared minus y squared, or whatever. X plus y times x minus y is the first one. So I'm using a formula number 3. I get same, different, plus. Same, different, plus. Okay, x and 3 are the two numbers that I'm cubing. X squared and 9, 3 squared is 9, are the two numbers at the beginning and end. And 3x would be in the middle. Okay, by the way, x squared plus xy plus y squared is always going to be in complete simplified form whenever you use this formula. Okay, so these two trinomials are always going to be in simplified form. So the next thing that I do is it's that x minus 3 equals 0 and x squared plus 3x plus 9 equals 0. X equals 3, that's going to be one answer, and that's something I can probably see right away. 27 minus 27 gives me 0. But there are going to be two other solutions to this, and the two other solutions are going to be found by solving this quadratic. So A is 1, B is 3, C is 9. I need the opposite of B, which is negative 3, plus or minus the square root of B squared. 3 squared is 9, minus 4 times A is 1, times C is 9, all over 2. Okay, and I get negative 3 plus or minus the square root of negative 27, all over 2. Square root of negative 27, well, that's the same as I root 27. And root 27, that's the same as 3 root 3. Okay, so negative 3 plus or minus 3i root 3 all over 2 is what I get. Okay, now these three numbers are the solutions to the equation x cubed minus 27 equals 0. Here's something that I just go over basically on my own. So a squared plus bx, ax squared plus b times x plus c equals 0. And I kind of derive the quadratic formula from that. So we get the quadratic formula exactly from completing the square. Okay, your book kind of talks about that a little bit. You can read about that if you'd like. So where does the quadratic formula come from? Well, it comes from completing the square. Exactly from completing the square. What somebody has done is they've made life way easier than what it could have been by completing the square for us. And they get down to a point where they get negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Way easier than what it could have been. Okay, so you're actually using the completing the square every single time, other than factoring. The only thing is that you're using the simplified form of that. Okay. Okay. So the problems are on page 211 and page 225. The homework, I've assigned the rest of 3.3, so basically the problems that involve imaginary terms are on page 225 here. Okay.